Today we will cover a cool project based on segment anything. Look at this demo. I'm clicking with the mouse on the face, on the dog face, and this is the first result, a star on the pointing area. And next, this is the first segmentation of the face of the dog. It was grabbed, extracted automatically. And this is another segmentation of the full dog based on this one click. This tutorial is part of a full playlist that deals with segmentation. You can find it here in this link. And next we will install the segment anything. In order to do that, this is the link for the installation tutorial. I covered it in a different video. However, it's very important to mention that I add to this installation guide free commands. These free commands install once again the Opencv library. It's very important. If you encounter any error during running Opencv, you should run these free commands. Okay, so let's start. We will import NumPy, we will import PyTorch and matplotlib in order to display images. And first of all, let's choose our image. I will leave this image along with all the code in a link in the video description. So this is the path for the dog image, and let's load this image using Opencv. Next, we have to convert it from BGR to RGB, and we will use this image variable in the segmentation process. As for now, we will continue to the next phase, which is building a function for clicking this image. We are sending the path of the image to this function. Let's create a new X and file variables that will store the position of the mouse click. Now we are loading the image, and let's add some text. Choose a point for the mouse click, and then we will click the Q key in order to exit the process. I will explain it later. So after loading the image and putting text along with the image, we continue to the next phase, which is creating a function for the mouse click, for the mouse event. So let's create another function inside our clicked function that will grab the event and the position of the X and Y. Now, if we grab the left button, if an event was launched while we click the left button, then we will draw a circle. As you can see, we are choosing the position of the click, the radius, which is 10, -1 means that it will be a filled circle, and we also storing the X and Y inside our variable, our chosen X and Y. Now let's create a window to set the callback function. Let's call the window select point. We're using the same name window for the named window and the mouse callback, and also sending the name of our function named mouse callback. It's very important, it should be the same text, the same name. Then we are displaying our image, and now we are waiting for a click. And if our keystroke is Q, then we will break our loop. So basically it's like we are running a loop that runs forever unless we click the Q button. Great. Then we are returning from the function the x and the y. And now we are ready to run our function. So our function will get the path of our image and will return the position of the mouse click. And afterwards, let's print the position x and y. Let's run it. As you can see, this is the image, and we are clicking, another click. You can see on the log the x and the y each time we are clicking on the dog. Great, it's working. And also we are creating a green circle on the image. Next, we will copy from the documentation of the segment anything free functions. We will use it later in order to display the annotations and the masks after the segmentation process. I will also leave here a link for those free functions, and of course there will be a link for the full code, so you don't have to type it during the video. Now we are ready to do the segmentation process. On the installation process, I'm explaining how to download the default model, which is named sam_vit_h. So I put it in a temporary file. This is the name. The device I'm using GPU, so the device should be CUDA. If you're not having a GPU, you can put a CPU and the same variable, and the model type will be default, which is sam_vit_h. Next, we are doing a registry process of our model type and the path for the checkpoints. Now let's define the model that we are using, a GPU. And now we are creating an instance of our prediction. Next, we are sending our image, and please notice this is the RGB image from the first line of this code. We are not sending the image from the function, we are sending the image which was converted to RGB. Now is the process of running the click process, running the mouse process in order to grab the X and Y. It's very important because this is relevant. It's part of the segmentation process. So we have to create two variables. One we call input point. It can be an array of points. I'm sending only 1 point of X and Y, and the second input label is 1 for foreground and 0 for background. We are sending 1 for foreground. Now we are displaying our image, and first time we will use the function show points in order to display the point of our click button. That will show this star, this small star, in the place that we put when we clicked with our mouse. So this PLT show will display the original image along with the star in the position of our mouse click. Now we are running the predictions. We'll use the predictor, and we are sending the point, input point and the input label, and we are using multi-mask true. That means that we will get 3 types of results. Each result will have its own score, so the model will try to predict a mask with 3 trials. First of all, let's print the shapes of the mask. We are expecting to see 3 shapes since the model returns 3 results, and this would be the shapes. It's the same shape of our original image, but we will have white and black areas. Okay, this is the image with the star and the position of the click. And now, as you can see, we have 3 images of these dimensions. Now we have to grab or extract the information of those 3 masks. So we will iterate through the masks and the scores, and we will display each of those masks. Let's create placeholders for the images, and let's show the image and also the mask. And we'll also show the point, this star, along with our required position. Let's add a title. Like image number 1 and the score of that image. It's basically not image, it's mask number 1. And let's also save each of those 3 images in the same folder of our original image. Let's name those images output. Let's name it output number 1, output number 2, and output number 3. So let's change the file name. Let's copy the full path. We will add the str of I, so it will be output 1, 2, and 3. Now let's put the file name as an argument, and now we are ready to run it. So let's wait for our original image. Let's click with the mouse. This is the position. Now this is the same image with the star on the position. Now we're expecting the first mask. As you can see, it's over the nose, and the score is 0.7. Let's see the next mask. The next mask is over the head with a higher score, and the last one is the full dog with the highest score. Great. As you can see, one click we are grabbing 3 images. We are also storing those images. Thank you very much. I hope you enjoyed this tutorial as well. You are most welcome to subscribe my channel. Bye bye.